Today we will discuss the distributive property of multiplication over addition. The distributive property is used to simplify expressions, although today it won't look like we're simplifying. And today we'll look primarily at integers, but it does work for all real numbers, as well as with algebraic expressions that represent real numbers. So let's get started. With the distributive property, multiplication is distributed or handed out to the parts of addition. So for all real numbers a, b, and c, we have the quantity b plus c, and it's multiplied to a. So we can distribute this a to b and c. Now, since subtraction can be converted into addition, it also works over subtraction. So on the left-hand side of these equal signs, what we have is the quantity 5 plus 2, and we have 3 of them. So we have 3 sets of 5 plus 2. And when we add these 3 sets of 5 plus 2, we get 21. Now if we distribute this 3 across both 5 and 2, we now have 3 sets of 5 and 3 sets of 2. And if we add up all those, once again we get 21. So whether we write it as the quantity 5 plus 2 multiplied by 3, or 3 times 5 plus 3 times 2, we end up with the same value. We use the distributive property to simplify expressions. So how we do this is we take the number being multiplied, in this case 7, and we distribute it to each of the terms being added. So now we have 7 times 3 plus 7 times 6. 7 times 3 is 21. And then 7 times 6 is 42. And we add those up and we get 63. Now we can also simplify this using order of operations. And when we're dealing with just integers, the order of operations may be simpler. So first we would do 3 plus 6, and that's going to give us 9. And then 7 times 9 is 63. So simplifying this expression, you can either use the distributive property or order of operations, which we will review in the next lesson. Now, since multiplication is commutative and the order does not matter, we can distribute this 4 that's on the right side as well and go 5 times 4. And then 2 times 4, or negative 2 times 4. We can write this as 5 times 4 minus 2 times 4. This is 20 minus 8. And that'll give us 12. And then again, using PEMDAS, or order of operations, 5 minus 2 is 3 times 4. And then that's equal to 12. For right now, practice using the distributive property, and then check your answer using order of operations. Now let's look at multiplying with a negative. And in this first case, we have a negative times the quantity of 7 plus 2 minus 3. So when we have a negative all by itself, it actually implies negative 1. So now we have negative 1 times 7, then negative 1 times 2, and then negative 1 times negative 3, or minus 3. So we'll have negative 1 times 7 plus negative 1 times 2 minus negative 1 times 3. Negative 1 times 7 is negative 7. And then negative 1 times 2 is negative 2. And then we have a minus, and then negative 1 times 3 is negative 3. So we have negative 7 minus 2 plus 3. If you notice, our signs here are now all the opposite of what they were here. We started with a positive 7. Now it's a negative 7. Positive 2 is now a negative 2. And then a minus 3, which is plus a negative 3. We're now at a positive 3. When we multiply something by a negative number, a negative 1, all the signs are going to flip. Negative 7 minus 2 is negative 9 plus 3, and that's negative 6. And then using PEMDAS, we have negative 1 times, well, 7 plus 2 is 9 minus 3, that's 6, and that simplifies to negative 6. Now we're multiplying by negative 3. And we're going to distribute the negative 3 to each of the items inside of the parentheses. So we'll have negative 3 times negative 12 minus negative 3 times 3. Negative 3 times a negative 12, that's a positive 36. Signs are the same, so it's positive. Keep the subtraction, and then negative 3 times 3, that's negative 9. This is 36 plus 9. Minus a negative is a positive, and that's 45. Positive 45. We have all these negatives, we end up with a positive. And then checking using PEMDAS, order of operations, we have negative 3. Negative 12 minus 3 is negative 15. Then negative 3 times a negative 15 is a positive 45. Now let's see how we can use the distributive property in real-world examples. So the turf on a football field is being replaced. The field is 100 yards long and 53 1/3 yards wide, not including the 2 end zones that each add 10 yards to the length of the field. Write an expression for the area of the field and then simplify that expression. So let's start with a picture, and we will draw a field. So we have a kind of a rectangle-shaped football field, and it's 100 yards long and 53 1/3 yard wide. But that doesn't include the 2 end zones. So let's draw our end zones, and they add 10 yards to each end. It gets longer, but not wider. So we want to write an expression for the area of the field. Well, the area of a rectangle is length times width. And our length in this case, well, the field itself is 100 yards plus 10 yards for each end zone. So there's our length. The width is 53 1/3. So a possible expression for the area of the field is the length, 100 plus 10 plus 10, all times the width. And the width is 53 1/3. And you could have moved this to the right side as well. So that is our expression. Now let's simplify this expression. So let's start by getting rid of this mixed number and converting it into an improper fraction. So 53 times 3 is 159 plus 1 is 160. So 160 all over 3. And then we're going to multiply 100 plus 10 plus 10. Multiply each of these out. 160 times 100. We had 160. Now we're multiplying by 100, so that adds 2 zeros. all over 3. Now we're multiplying by 10, so 160 becomes 1600. And then another 1600 all over 3. Now we're adding fractions. We have a common denominator. That common denominator is 3. So now we have, add those up, and we get 19,200, all divided by 3. And this is 6,400 yards. And since this is yards times yards, this is area, this is yards squared. We could have also done this with order of operations. So we have 53 1/3 times 120. Convert this into our improper fraction. We have 160 over 3 times 120. We'll do this as 120 over 1. This cancels out here. We have a 40. Now we have 160 times 40. And once again, that's 6,400 yards squared. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 4 problems. As we did earlier, we're going to simplify these using the distributive property and then check our answer using order of operations. Now, quite often, order of operations is the simpler approach when dealing only with numbers, particularly integers. But here we are practicing using that distributive property because it will become essential when we are looking at algebraic expressions. And then finally, an 8-foot wide sandbox will be added to the entire north end of a square playground. If the length of the sides of the playground is 50 feet, what is the area of the playground after the sandbox is added? Again, as you do these story problems, always start with a picture. So we have a square playground, and the sides are each 50 feet long. And then to this playground, to the north end of the playground, we are going to add a sandbox. And that sandbox will be the entire length of the north end of the playground, and it'll be 8 feet wide. So this right here is our sandbox. It's 8 feet wide. So now when we look at area, we're looking at length times width. And so deciding what your length is, I'm going to go with the length being this side here will be our length. Although it does not matter if you make this the width. And then this is our width here. So our length, well, it's 50 feet plus that additional 8 feet that adds the sandbox. And then the width is 50. And then that gives us this equation here. Resulting in the area of the playground with the sandbox is now 2,900 feet squared. Keep practicing working with the distributive property, and I'll see you in the next video.